Hello guys, welcome to our last video. In this video we're going to talk about thermal expansion. Thermal expansion is the behavior when a substance is heated and its particles move faster and spread further apart. This causes the material to expand. So, in my own words, thermal expansion is when a substance, whether a solid, liquid, or a gas, is heated, and this heat causes the material to the particles of the material to move faster, and this causes expansion. Expansion can be bigger in gases than solids, because in the gases the particles are more further apart than the solids. The particles are very together. Thermal expansion in solids. So in solids, particles are very close packed. So expansion acts in a small way, but it's still noticeable. So in here we can see in the example that the particles are very close together in the case of the solid. Here we have a real life example. Hot water is used to expand the metal lid of the jar. So this acts that the water hits the lid and the lid expands because it's made of metal, and the particles move faster and it causes it to expand. So the thermal expansion in liquids acts the same way as the solids, but in this case, liquids expand more than the solids because their particles are less tightly bound. Here we have a real life example of thermal expansion in liquids. As we can see, when in 70 degrees, the level of the water is below the half of the container. So as the temperature increases, we can see that water even gets outside of the container. In the case of the gases expand the most because their particles are more far apart than solids or liquids. And they move freely. So here we have the three formulas. First, we're going to start with solids, in which L0 stands for the original length. Alpha stands for the coefficient of linear expansion. And change in temperature stands for the difference in temperature. Now with liquids, B0 stands for the original volume. Beta stands for the coefficient of volume expansion. And change in temperature stands for the difference in temperature. With gases, B0 starts for original volume. Gamma stands for coefficient of volume expansion. Change in temperature stands for the difference in temperature. Here we have an example. A steel rod is 2.0 meters long at 20 degrees Celsius. If the temperature rises to 80 degrees Celsius, find its increase in length. The coefficient of linear expansion for steel is 1.2 times 10 minus 5 degrees Celsius. Now, as we can see, the exercise stands for solid expansion because it is talking about a steel rod. And now we proceed to look for the data. So we identify the data and place it in the formula. This is a multiplication, and the result of this multiplication is 0.00144 meters.